Welcome to the Bodhi Academy. My name is Amisha Kulaso, and in today's video we will continue with our chapter Introduction to Graphs, Class 8, Chapter 13. So previously in this chapter we learned about line graphs, and then we learned how to interpret them based on the information that they provide. Now in today's class we will see some of the applications of this line graphs. So if we look in everyday life, what we observe is that the facility we use has some kind of amount or charges that we have to pay. With reference, if we talk about electricity, okay, so we have electricity, okay, and for this usage what we have to pay is the electricity bills. Okay, so this is the electricity bills. Now in this case what we can see is that if we use more electricity, the bill will be more. Okay, so these are two dependent variables. Okay, now if we look closely and understand electricity, okay, if we look at electricity becomes a independent variable. Electricity becomes an independent variable. Now why so? Because using electricity in tent has no other effect on somebody else. Okay, it is not creating any other effect on something else, provided if we look at electricity bills. So electricity bills, if you look, it is a dependent variable. Dependent variable as in it is interdependent on the amount of electricity that you use. Okay, so it depends on the amount of electricity that you use. Okay, so electricity is an independent variable, but electricity bill is a dependent variable because that will vary depending on how much of electricity we are using. So these are two important terms. Now let's try to understand the relation between such variables, how they can be shown in a given graph. Now example 3, first is the quantity and cost. In this, now see, we have number of liters of petrol, that is 10, 15, 20 and 25, and then we have the cost of petrol in rupees, that is 500, 750, 1000 and 1250. Now what do we see here is that there is a gradual increase. Okay, so these number of liter of petrol depends on the cost. Okay, more the number of liter of petrol you are taking, higher is the cost. So as you go, as the liter increases, the cost also increases. Now let us make a suitable scale for both the axes. Now if we talk about scale, it is this x-axis that we have. This is our one scale, and the y-axis, this one here, is our second scale. So now in this, first what we have to do is we have to choose the scale that we are going for. So on x-axis we will consider the liters, that is how much of petrol is being used, and on the y-axis we are going to consider the cost. So if you look at the liters, it is starting from 10 to 25. So if you have to plot it on a graph, it is always advised to plot it like, if this is my A, okay, and this is my BC. So you have to plot it like A minus 5 and B plus 5 range. So if I do A minus 5, if I do A is 10 minus 5, so I have to start with 5 liters, like the scale will start with 5 liters, and if I have to do B plus 5, that is 25 plus 5, that will be 30 liters. So my scale will end at 30 liter. So that is the information that will go on my x-axis. Now for the cost, if you look, we have to apply the same theory over here. So now in this case, because we are starting with 500, we can take directly the least, that is 100 we can start from, and we can go up till 1300. So this is the maximum scale that we can go up to. Next, after that, these points which are given, okay, so you start by marking the point on the x-axis, that is 10. So if you look, we have 10 over here. Okay, at this point we have 10 liters and the cost for 10 is, they are saying it is 500. So you have to start from 10, go up till this line, this adjoining line you have to go, and then you have to see where this 500 line intersects with the 10 liter line. So that becomes our point 1. Okay, then similarly go for 15 liters. So same way you draw a extending vertical line and then you see the corresponding horizontal line that is coming in contact with it, that is at this point. Okay, so these, like this we have to mark all the given points with reference to the cost of the petrol and the number of liters of petrol that we get. Then further you have to just join the all the points. That is what we do basically in a line graph. That is the same we have to continue to do here. Now this is the graph of situation in which two quantities are in direct variation. So direct variation as in, if you look, if the number of liters of petrol is increasing, this is 10, this is, the cost is 500. Then if then it increases more to 15, the cost is also increasing, none of it is decreasing. So therefore we can say that they are in a direct variation, that is they are directly proportional to each other. In such cases always the graph will be a linear graph. Now let's look at another example. Now in this we have a principal and a simple interest. So say a bank gives 10% interest on deposits by senior citizens. We have to draw a graph to illustrate the relation between the sum deposited and the simple interest earned. Find from your graph. So first is what? The annual interest obtainable for an investment of rupees 250. Second, the investment one has to make to get an annual simple interest of 70 rupees. So first you have to find for each deposition of say 100, 200, what will be the simple interest that we will be getting for a year, that is in terms of rupees. Here they have given that it will be 10%. Here we have to find it how much is the value going to be in terms of rupees. So if say we are depositing 100 rupees, in that case we'll have 100, that is the cost, into 1, that is the year, into 10% which is there upon 100. So in this case this will go and this will go, so we will be only left with 10. So for 1 year we will get 10 if we deposit 100 as the amount. Then if you go to 200 you will get a simple interest for a year of 20 rupees. 300 if you deposit you get an interest of 30, and so on. If you go till 1000 you get a interest of 100 rupees. Now same steps have to be followed. So one is deposit and then next is annual simple interest that we are going to obtain. Similar way we have to first decide the two x's, then we have to do a minus 5 or whatever the least quantity is, and then add it so that we get the highest value. Then plot all the corresponding points. So in this case also what we will see is that it is again a linear graph. So what we can say that it is a variation, it is a direct variation graph. In this also if you see depending on the sum that you deposit, the simple interest for a given year is also increasing. Now lastly let's look at this example of time and distance. Ajit can ride a scooter constantly at a speed of 30 km per hour. Draw a time distance graph for this situation. Use it to find first time taken by Ajit to ride 75 km and second the distance covered by Ajit in 1/2 hours. Okay, so the solution. So hours of ride is 1. So in the distance covered will be 30 kilometers. Hours of ride if it is 2, then the distance covered will be 2 into 30. So that comes up to 60 kilometers. 3 hours it will be 3 into 30, that will be 90 kilometers, and 4 into 30 will be 120 kilometers, and so on. Similarly we obtain the table of the time in hours with corresponding the distance that is covered in kilometers. Then now here on the x-axis we have taken the time that is in hours, and on the y-axis we have the distance that is covered in kilometers. Here also what we see is that we are getting a linear graph that indicates that there is a direct variation. because the amount of time increases, more distance you will be covering. Okay, so this kind of data can also be interpreted from a given graph or line graph. Okay, so that was it for this chapter. Please don't forget to like, share and subscribe to the Bodhi Academy. Thank you.